Junior Cycle Higher Level 2013, Paper 1, Question 2. This is a sets question, and you're told that the universal set is, by virtue of the dot to dots, we're assuming that every single whole number from 1 up to 12, 1, 2, 3, and we're assuming 4, 5, 6, 7, 8, 9, 10, 11, 12. And those numbers can go somewhere in this universal set. P is a set of prime numbers less than 12, E is a set of even numbers less than 12, and O is a set of odd numbers less than 12. So we're asked to put those various different elements into a Venn diagram. So the prime numbers less than 12, well, we have 2, 3, 5, and 7, and lastly 11. Then we have E, that's the evens, so we have 2, 4, 6, 8, 10, and I'll put out 12 is not included because it says evens less than 12. And then lastly we have the odds, and that's 1, 3, 5, 7, 9, 11, all less than 12. And so now we can put them into our Venn diagram. We obviously have to work out which ones are in more than one set and which ones are in just one set only, or possibly some numbers won't be in any of the sets. Now often I'd say is focus on the ones that appear in more than one set, but to a certain extent, because it's a very simple set of values, 1 to 12, you might as well just go through 1 to 12 and say each time which sets are they in. So 1, which sets is 1 in, it's just an O only, so we can put it in the section that's for O only. For 2, we have it in P and in E, but not in O. So it's going to go in the intersection between P and E. There's 2 there. The next value is 3. Well, 3 appears in P and in O, but not in E. So we're in the intersection of P and O. For 4, 4 appears in the evens and evens only. So 5 appears in the primes and the odds, so that's in P and O, the intersection of P and O. So 5 goes there. 6 appears in E only. 7 appears in the primes and the odds. 8 appears in the evens only. 9 appears in the odds only. 10 appears in the evens only. 11 appears both in the primes and the odds. And then 12 appears in none of them. So we have all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're all in there somewhere. And just to double check, if we can think about it, we have no elements in the intersection of E and O because the evens and the odds are mutually exclusive. A number can't be in both evens and odds. So it makes sense that section there should be empty. And likewise, if you think of all the primes, the prime numbers, they're either even or they're odd. So they're either going to be in the even section or they're going to be in the odd section. They're not going to be outside of those two options because they have to be in one or the other. Effectively, we can say the primes are a subset of the union of the evens and odds. And moving on to part B, if we want to look at what is a null set. Null cell is an empty set, so we've got two choices, as already discussed. We've got this section here, which is the P only, or we've got the intersection of E and O. So as a answer, there's two options. We either have the intersection of E and O, that would be an appropriate answer, or alternatively, as an alternative answer, we could talk about the section that's P only. So to describe the P only bit, we have to say we've got set P and we are going to less, i.e. take away from that anything that is in E or O. So if I take away the union of E and O, away from P, I'm left with that section that I call P only. Moving on to part C, we're asked about picking a number at random from set P. So we're talking about this set here, P only. There are 1, 2, 3, 4, 5 elements, 1, 2, 3, 4, 5. And what's the probability that the number would be even? Well, how many are even out of that set of numbers? Is a 1 out of 5. So the probability would be 1/5. You can write 20% or 0.2 if you wish.